Hello everyone, so now we're looking at our not-so-perfect storm solution. Okay, so let's take a look. So again, this is the piece of energy here, this storm that's going to be funneling in warm air for this weekend and into early next week along this entire area here. So let's move along here. So we're on Sunday now. Is that too far? No. Alright, so now here's what's going to happen. This is Monday for the American model. You have your piece of energy coming into the Pacific Northwest. Your northern branch of energy is still way up there. It's not down here yet. I'm sorry, I went back. This is where we were. Let's continue moving along. So it's going to come east. It's going to move south, southeast. Watch, it strengthens. And now your northern piece of energy is up here, coming down. Alright, we were, I think, right here, just about. The American model is extremely slow with this. So here we are. Now, the European moves this south and east a lot quicker. And it has this piece of energy up here phasing with this. The American model does not have these two pieces of energy phasing together. That is the main difference, and it makes a significant difference. Do you want to know why here? Because watch what's going to happen. Rather than having a Pacific moisture here forming a storm, you have a short wave coming down from Canada that's going to form the storm. These two pieces of energy stay separate. So you want to know what happens? You get a much weaker storm. That's the first thing. So here we are. This short wave is still really strong, don't get me wrong. But the problem is, I think this is too far north to be taking in Gulf moisture. And I think that's the main problem. You're still going to be taking in Atlantic moisture, but you're not going to be taking in moisture from both areas of water here. That means there's not going to be as much precipitation associated with the storm as with the European solution. So if you take a look, sorry, this is where we were. Sorry, I know I keep screwing that up. I apologize. For this to be the perfect storm solution, and also notice the jet stream is further north. That's the next thing. This piece of energy and this piece of energy would have to combine, like it's shown as shown in the European model. Now, here we go. And then it moves out to sea. It's still strengthening though. So as you can see, it strengthens the storm when it's already off the coast. Let's take a look at our low pressure map. This way I can show you. So here it is. That's from the southern piece of energy. Then this northern piece of energy comes down, but keeps the southern energy separate. So this is going to form the storm and move it east. Then this piece of energy is going to take over the storm and move it northeast up the coast. Sorry, we were there. Now, watch. That's pretty puny, if you ask me. It's not really that strong. It strengthens there, but by that time it's pretty much out to sea already. Okay, so and this track is a little too far east for comfort for me. I'd like it to be a little bit further west. So if you take a look at your precipitation map. So let's watch here. This is early on Wednesday. You have light snow about to come in. There it goes. The storm strengthens, but look at that. That's not really heavy precipitation. That's moderate at least. So, what's my conclusion here? Oh, and also I just want to check something here. And if you notice, you still have an area of high pressure up here, so this is going to be funneling in Arctic air as well. Now, what's my thinking here? Based on the American model, if the American model solution comes into play, then it would be number one, it would be a weaker storm. And number two, northern portions of New England would probably escape any snow at all. Because looks like it's going more out to sea. So if this solution comes through, you'd probably get a band of snow in this area here. Well, probably not that far south, but in this, it would be a very narrow band, right in this area here. So Connecticut, Massachusetts, Rhode Island, Long Island, New York City, northern New Jersey, eastern portions of Pennsylvania, you would get a band of snow, and probably extending back into this area here. Or actually, no, probably further down south, because this track is further south. So that's what would happen with the GFS. And there's another representation that I can show you here.